Hello, meteorologist Brett Anderson here in the 1011 Weather Center. We are going to start our weather workshop in less than 2 minutes. Today we're talking about rainforests and deserts, so in about another minute and a half and we'll get started. And good afternoon. Welcome to another 1011 workshop, weather workshop. And again, we've been discussing quite a few topics over the last few weeks, over the last couple of months. And now we're going to talk a little bit about rainforests and deserts. Just kind of chose kind of two extremes where some places in the world get a lot of rain and other areas get very little precipitation. So we're going to talk a little bit about climatology. We're not going to go into too much depth with climatology because that is a complicated subject. There's a lot of things to talk about. There's all kinds of climates all over the world. So we're going to just kind of focus a little bit on Nebraska, just kind of give you an idea what our climate is, and then compare that to some of the rainforests and deserts and how they form. So again, we often talk about weather and climate. So weather is not climate. So the daily weather that we have is not climate. Basically, an easy understanding of this is climate is what you expect, but weather is what you get. You can kind of think of it this way, that weather is what you wear day to day, but climate is everything in your entire closet. So again, weather is not climate. So we're going to be talking a little bit more about climate, what we expect in certain parts of the world. Now, there are a lot of factors that go into climates across the world, certain different kinds of climates. If it's hot, if it's cold, if it's if it's wet and dry. There's topography, and we will talk a little bit about topography today. That is mountains and valleys. That's what we mean by topography, elevation. We're going to be talking about something called the Hadley cells. We won't go into deep concentration on that, but basically Hadley cells are a kind of a rotation in the atmosphere. And then ocean currents play a big factor in climate. Greenhouse gases, those are like carbon dioxide, methane, water vapor. Those are greenhouse gases. A lot of these are natural, but some of these are human influence, like land use changes. If you at once had a forest in one area and then that gets all cut down, that changes the climate of that area. Also population growth, what we may call urban sprawl, where the cities start to grow out and take over the countryside. That can change a local climate. There's also other things that drive climate is latitude, where we are on the earth, whether we're in the far northern part of, closer to the North Pole, closer to the South Pole, or in the middle. Latitude is a big thing. And then another thing we call ENSO, and that's really kind of do with El Nino and La Nina, something that you may hear from time to time. Every once in a while, there's a cooling in the Pacific Ocean, and that leads to the La Nina phase, which can interrupt the kind of the weather patterns. And then the El Nino is a warming of the Pacific waters, especially the eastern Pacific waters, down by Peru, places like that, northern areas of South America. So we do watch that because it can affect world weather. There might be a La Nina starting this year. It's a little bit earlier, but a La Nina means cooler ocean waters, and that may have some impact on our weather. So again, those are some of the things that impact climates across the world. Now, there's a climate classification that we're going to be talking about in just a second, and basically, you kind of put all these letters together. So in some parts of the world, you can have an A, and then an F, and then maybe a C, or basically an A or an F would be tropical year-round. So you can kind of put these letters together. So it's kind of, again, this classification system is complicated, and it's something that would take several lessons. If we were actually in a classroom setting, we'd be talking about this for several days. So let's talk a little bit about what we're talking about, the Köppen-Geiger climate classification, if you will, how we classify climate. Now, there's a lot of colors here, and there's a lot of letters, a lot of codes and stuff like that, but basically what we'll talk about, we'll just kind of give you an idea what kind of climate we have here in Nebraska. So the kind of the dark purple area where you see that in central and eastern sections of the state, that's what we basically is classified as what is a humid continental. The summers are hot and humid, and the winters are cold. Not necessarily wet, but the winters can be quite cold and harsh from time to time. Now, you'll notice over far southern Nebraska, starting to get into northern Kansas, that's more trending towards milder winter, still a hot summer, and maybe a little more adequate moisture, especially for far southern Nebraska and northern areas of Kansas. And then in western Nebraska, where you see the kind of the brown or the tannish, that is what we call semi-arid. If you've ever been to western Nebraska, or if you've lived in western Nebraska, it's a little bit drier there. The summers are still hot. The winters can still be cold, although somewhat maybe milder than maybe portions of northern and northeast Nebraska. The summers are still hot, but not as humid, and places like Scotts Bluff don't get as much precipitation as people do in eastern areas like Columbus, Lincoln, or Beatrice. So that's just kind of a quick look at what we expect across the state of Nebraska. So we do have some different climates, and one of the reasons why it's drier in the western parts of the state is because of the Rocky Mountains. We're going to talk about why the Rocky Mountains make it somewhat drier for places like Scotts Bluff, Cheyenne, Denver, and far western and southwest Nebraska. Now we zoom out here, and that's just kind of a look at the whole country. That green area, Dallas, Houston, again, that is that area where we see the mild winters, but still the hot, muggy summers, and there's more adequate moisture, wet throughout the year for the most part. Atlanta, Houston, Dallas, but then you get over towards El Paso and Las Vegas. Those are your desert areas. And again, we'll be talking more about that in just a little bit. Another factor for climates of the world are the ocean currents. And the blue currents indicate cold waters off the coasts, and of course the orange ones or the red ones are the warmer waters. So when you have a warm current nearby or near the land or by cities, usually that climate is going to be a little bit warmer. Now, if you have a colder water current near you, like by California, you can see right here, that's a cold current there. Usually along the coast, especially, it doesn't get that warm. Occasionally they do get hot, but most of the time it's kind of a moderate climate for places like San Francisco and also Los Angeles. One of the funny things about San Francisco is a lot of times they get if the wind is from the ocean, from the Pacific Ocean, they can a lot of times have cloudy, cool days. There's something called the June gloom in San Francisco, Brandon. And I believe, if I'm saying this right, of this quote, Mark Twain once spent a summer, or maybe several, but I know what he said about summer was this quote, Mark Twain: "The coldest winter I ever spent was in summer in San Francisco." Yeah. That's clever. I mean, because sometimes it can stay like only in the 50s and 60s in June in San Francisco because the predominant flow is off that cold Pacific Ocean. So again, that's just kind of an example of how especially coastal places, coastal communities can be affected by the current. You talk about the temperature could be cool and comfortable on the coast, but you go inland a few, 10, 20, 25 miles, and actually it can get much hotter because you're away from the influence of the currents. Okay, now we're going to talk about wind and pressure. And there's the Earth again. We're going to be talking about the trade winds. Now you'll notice that this is kind of right along the equator. It's called the trade winds. And what happens in this sector is the trade winds, they converge. You can see how they converge right along the equator, or what we also call the intertropical convergence zone. More on that in just a bit. Then as we get into our part of the country, where Nebraska is, we have predominantly a westerly flow, especially the upper levels. That's why our storm systems, our big low pressure systems, high pressure, usually travel from west to east across the country, because we're predominantly in the westerlies. And then as we head towards the poles, it's what we call the polar easterlies, where the wind is predominantly out of the east. Now there's the ITZ. That is the International Tropic Convergence Zone, okay? And what this is that's where the trade winds from the southern hemisphere and the northern hemisphere converge. This area can be very wet. Because of this convergence, it forces the showers, it forces the moisture upward, and gives us numerous showers and thunderstorms. So this can be a very wet area right along this pink area, this International Tropic Convergence Zone. So then we talk about the subtropical high pressures. Now remember what high pressure is. High pressure is sinking air, and these subtropical high pressure systems just kind of linger in the same area. They don't move much. They're not moving through across the country, or across the world, I should say. They are really permanent or semi-permanent high pressure systems. And again, remember, sinking air. Now I'm showing you some tropical rainforests, because remember I showed you where we had that convergence. That's where the showers and thunderstorms are. That's where it's very wet. Well, that gives us our tropical rainforests in many locations. This is where it's warm and tropical. It is a frost-free area. They don't get snow here ever in these tropical rainforests at average levels or sea levels. So basically, tropical rainforests like the Amazon in Brazil, like where I visited in February, places like Panama and Costa Rica, where these pictures were taken, are tropical rainforests. They get a lot of rain, and of course it never snows, and it's pretty warm all year round. So now I'm going to show you kind of another map of the world, and now check it out. There's the Amazon right there. That is where we have the convergence of the trade winds, and that's where we usually get our thunderstorm activity. So there's tropical rainforest jungles in much of portions of South America. Brazil, as I mentioned, you can kind of see it goes up there into Honduras, Nicaragua, El Salvador, Panama, Costa Rica, Colombia. Then you head over to Africa, center of Africa, again right along the equator or that convergence zone. We basically have more tropical jungles, tropical rainforests, and then portions of Southeast Asia, Indonesia, all looking at very wet conditions. So I wanted you to notice that part. But now watch what happens when we have these subtropical high pressure belts, basically right around 23.5 degrees to 30 degrees. These semi-permanent high pressure systems just sit. And because of the sinking air, very little rainfall occurs, very little cloud cover occurs in these areas. So that is why they're dry. Now take a look. There's Africa, that's a dry area. And then also parts of Australia, parts of southern Africa, and parts of southern South America. Also these subtropical highs are there, and also in southwestern portions of the United States or North America. So again, that's where we have some of the world's biggest deserts. Now the Sahara Desert is primarily due to these subtropical high pressure systems. You can see it's by an ocean, but because of the sinking air, that moisture that comes off the Mediterranean or the Atlantic just never really can develop into clouds or rain because of the sinking air. The Sahara Desert is the biggest desert outside the polar areas. More on that in just a bit. And this desert is typically very hot and very dry. There's also other deserts like the Sahara in Australia, southern Africa called the Kalahari, and also in portions of South America. So we'll be talking about that, and you've probably all seen pictures of the Sahara Desert. A lot of times the scenes look like this, a lot of sand dunes, not very much vegetation, and again, very hot, and it is the largest desert outside of the polar areas. Another desert which isn't very far away from the Sahara is the Arabian Desert. This is the Saudi Arabia Peninsula, if you will. Again, it's just to the east of the Sahara, but still under that subtropical high, that sinking air. So again, not a lot of moisture falling in places like Saudi Arabia. All right, another area where we have a subtropical high is actually the southwestern portions of the United States down into northern areas of Mexico. We certainly have desert areas. If you've ever been to New Mexico or Arizona, you'll know that it does look like a desert, and it's partially due to the subtropical highs with the sinking air. And this is a common scene in Arizona, especially around the Phoenix area, central southern portions of the state of Arizona. Okay, so now we're going to talk about another kind of desert, maybe another kind of rainforest, if you will. We're talking about rain shadows. Now, this is where the mountains come in. This is where topography starts to take a play of why we have deserts and wet areas. So basically, if you have a mountain range, you have a prevailing wind which brings moisture from the ocean. But the mountains force that moisture upward. And you know what happens once the warm moisture starts to rise, it cools, it starts to condenses into clouds and precipitation. So generally, as the precipitation gets too heavy, it starts to fall on what we call the windward side of these mountains. And on that windward side, of course, during the winter, a lot of locations see snow. So that's why places like Colorado and Utah and Idaho, Montana, they all have great skiing there because on the windward side of those mountains, they get a lot of precipitation, and most of it is snow during the wintertime. All right, now, of course, during summer, or if it's a little bit warmer, it's what we call a temperate rainforest. This would be up by Seattle and the Pacific Northwest, along the Pacific Ocean, Oregon, Washington, into southwestern areas of Canada. Now, it's a rainforest. They get a lot of rainfall here, but it also can snow here. This is different from the tropical rainforest because here it can freeze from time to time, frosty conditions, and of course, during the winter, if enough cold air moves in, they can have a lot of snow. And of course, the vegetation here, a lot of ferns, a lot of moss growing on everything. So that is what we call a temperate rainforest. So now we continue. So now we have the windward side where we get all the rain and the snow. But once the air goes over the mountain, it starts to go down the other side of the mountain. Well, this is a warming process. This is a drying process. And since the air is going down, it is warming. It's just kind of like rubbing your hands together. You start actually getting a little bit of friction. So you start getting warming, which warm air holds more moisture. So therefore, we don't see cloud development. And there's a lot less relative humidity. And therefore, you have the rain shadow region. That's why it's called a rain shadow, because the rain just doesn't make it over. And so you have very dry conditions. So once again, on the windward side, we have ample moisture, snow, rain, lush, moist vegetation. And then on the rain shadow side, we have the very dry conditions. And that's the drier climates. So now we're going to take a look at some of the deserts of the world. This is the Gobi Desert, and this is primarily in China. And the Gobi Desert is an example of a rain shadow. It's not only a rain shadow, but it's also due to that area of high pressure we talked about, the subtropical high pressure, at least on the northern side of that. Now, the Gobi Desert is also what we call a cold desert, or maybe a higher elevation type desert. It's a higher elevation, so it does get hot in the summer. It does get very hot in the Gobi Desert in the summer, but it also can get very cold in the winter, just as cold as it is here in Nebraska, well below zero. Now, they don't get a lot of snow, they don't get a lot of moisture, but this is a hot summer, very cold desert where they, of course, can see snow if there's moisture. So that's an example of the Gobi Desert, which is a rain shadow desert. Another example, even here in the United States, of a rain shadow desert is what we call the Great Basin. You see this Sierra Nevada here? This is a mountain range in California. It's a big, tall mountain range. So as we just talked about, all the moisture that comes in from the Pacific on the windward side falls as rain and snow, but then it's all downslope or the rain shadow. So this Great Basin area of Nevada into Utah is very dry, very little moisture. Another example in the United States of a rain shadow desert is one of the driest places in the United States, and that is Death Valley. Not only does Death Valley have the notion of the hottest temperature ever recorded in the world of 134 degrees, it is also very dry. In the mountains, again, of Southern California, the Pacific moisture, it all falls on the other side of the mountains, the windward side, but by the time that air flows over the mountains, it is dry and it is warmer. All right, now we're going to talk about South America. This desert is called the Atacama Desert, and this is a very interesting desert. This is the driest desert in the world. It is also the oldest desert in the world. And basically, you're talking about, you've got the mountains here, basically the huge mountains of Chile, and this is primarily located over Chile. And so you've got kind of a double effect here, because you basically are looking at very dry conditions because of the mountains, and then you have coastal mountains. And so there's kind of a double rain show, because sometimes there's moisture comes off the Pacific, can't get over those coastal mountains, but then the big mountains, you have the descending air, and of course you have dry conditions. So Chile, rain shadow, partially also due to the subtropical high, sinking air. This is the right latitude for that. It is the oldest desert, as I mentioned, 150 million years old, and it's also the driest. The precipitation, if you were in Lincoln today, we had about 13/100ths here at the 1011 studios. That's not a lot. And in some locations in this desert, they have even less than what we saw today in an entire year. The average for this desert is about 1/2 an inch of moisture. That is very little. Compare that to Lincoln, where we have about 28 inches on average a year. There are some recording stations that have never recorded any rainfall. So this is the driest desert. A lot of times some of the astronauts will come and train here because the conditions, or at least the terrain, is very similar to Mars. Now, of course, Mars doesn't have oxygen where we can breathe and stuff, but it's extremely dry and it's very barren. There's not a lot of life here. There's not a lot of vegetation. There's just not a lot going on because of the lack of moisture. And now, Brandon, get ready for this. The biggest desert in the world is
Antarctica.
Antarctica. Thanks for playing along, Brandon. That is right. I know it's hard to believe, but with all that snow and all that ice, it is actually one of the driest places on the planet, not only the Antarctica, but the North Pole region as well. One of the reasons, again, it is so cold here that very, very little moisture develops. Basically, the Antarctica sees an average of about 6 inches of moisture, about 3 to 6 inches of moisture a year. And this is the biggest as far as land surface. Now, the reason why you see all that snow is because snow and ice has been accumulating for thousands of years. It just doesn't melt. So you don't get a lot of snowfall during the winter. You don't get a lot of rainfall, but the snow that does fall never melts. And eventually it just stays there and it blows around, or eventually it compacts and becomes ice and a glacier. So basically, Antarctica is a desert. All right, so we've kind of talked about all that. Again, want to thank meteorologist Jan Reichert for making some of these graphics for us to explain all about rain shadows and deserts. So I'm going to go to Brandon now, and Brandon's been watching your questions. So what do we have? Brandon? Any good questions today?
Well, I think Becky's trying to ask on some of these deserts, do they get snow? And I think that kind of popped up before you revealed that Antarctica is a desert. So
right.
Deserts can get snow.
They do. They can get snow. As I mentioned, the Gobi Desert, we'll go back there, which is in portions of China. It's a high desert, but it's also far enough north, and because of the higher elevation, they actually do get snow. Now, again, they don't get a lot, but it does get very, very cold. And the Gobi Desert is in China and also a big part of Mongolia. I should have mentioned that. Mongolia, the country of Mongolia, check your atlas on that, your map, to find where that is. Much of Mongolia is the Gobi Desert. And so it's, again, very dry, but it can get very cold. I've seen temperatures, in the winter from Mongolia about 25, 30, 35 degrees below zero from time to time. And if there is some moisture, there will be some snow in Mongolia. Also, occasionally, even the desert Southwest in the United States can get some snow if it gets cold enough. If you can look this up, I've seen pictures of snow on cactuses, so it is possible. So yeah, to answer your question, it does snow. Now, believe it or not, we've talked about the Sahara Desert. That is also, basically, it's a hot, dry desert. But every once in a while, doesn't happen very often, parts of the Sahara Desert can get a little bit of snow. There was a couple years ago, Brandon, right, where there was some snow in places like Egypt and Libya where they had some snow. Again, doesn't happen very often, but it certainly can happen.
While we're talking about deserts, Jen wants to know, what is the hottest desert?
The hottest desert is the Sahara Desert. On average, they do see the hottest conditions. Now, as I mentioned, though, Death Valley has the hottest temperature ever recorded on the planet, with 134 degrees. But really, the Sahara Desert is the hottest, statistically and climatologically speaking, the hottest in the world.
All right. This question was from a different Jen.
Okay.
When it was raining yesterday, I was wondering why the rain was cold.
The rain was cold because the temperature was chilly. You know, it was coming from the clouds where it's colder there, of course, and it really wasn't that warm here. We were only in the 50s. So, of course, that means it's cold. You know, sometimes in the summer when it's really hot outside, you might get a shower. And, of course, the rain is always going to be a bit cooler. But sometimes that rain is nice and warm and you can go play on it, as long as there's no lightning. You know, never go play in rain when there's lightning. But sometimes you can go out in those summer showers and it feels a lot better. But if the air temperature is cold, that means, you know, a lot of times the rain actually started off as snow in the clouds and then melted on the way down and became cold raindrops. So that is why it was a cold rain yesterday.
Renee wants to know, how is a snow desert considered a desert?
Because it has to do with the amount of moisture it sees. So even though it sees snow, it doesn't see a lot of snow. Remember, most of the deserts around the world, or to be classified as a desert, you have to have 10 inches of moisture, whether that's melted snow or rain, 10 inches or less. And like I said, the Atacama Desert, some areas don't even pick up an inch of rain. Some of them don't even pick up a quarter of an inch of rain. Some areas haven't even recorded rain in the last decade. So it all depends on the amount of moisture. So that's one of the reasons why I wanted to talk about deserts, because a lot of times, you know, in our minds, when we think of desert, we think it's hot and that's it, just hot desert. But that's not always the case, because technically Antarctica is a desert, and places like the Gobi Desert, which gets very, very cold and sometimes gets snow, is still classified as a desert.
All right, Owen's got a good question for you.
All right.
What is bigger, a rainforest or a desert?
Well, it kind of depends on where you are. Let's see, we'll go back to some of these, this world map here that I had. And there does appear to be a lot more desert area than rainforest area. If you take a look at this, you can see southwestern areas of the United States, that's a desert area. Look at the huge area of northern Africa. That's the Sahara. Then we got desert conditions in Saudi Arabia, places like Iran, and then you get into Mongolia and portions of China. You got a lot of desert area there. Then you have Australia. A good part of Australia is a desert. Not all of it, but a good part, especially the interior. And then you have southern Africa, the Kalahari Desert, and then you have the Atacama Desert in portions of Chile or southern areas of South America. But you'll notice that portions of South America, pretty large area there of a rainforest, part of the Amazon. Now that's the biggest rainforest in the world. Then you've got the jungles, the rainforest, tropical rainforest of Africa. And then there is a pretty expansive area of jungle from southeast Nebraska, Southeast Asia, places like Vietnam and Thailand, and then you go down to Indonesia, Malaysia. You have a lot of tropical rainforest there. So by land, it appears that there's a lot more desert areas, because you also have to remember, you got to count Antarctica. That's technically a desert as well, and then also the northern portions of the world near the North Pole, the Arctic Circle, also very dry conditions.
All right.
That's it?
That's all I've got right now.
Wow, I've answered all the questions. That's great. Well, again, thank you. I want to thank Allo once again for helping us with this project. I hope you learned about deserts. I always thought as a kid, that deserts were hot. That's what a desert was. It was just hot. But we know now that deserts are basically classified as deserts because they see about 10 inches of precipitation or less a year. So that doesn't mean if it's hot or cold, it's still a desert. So that is why we have Antarctica as a desert. Oh, okay. We have one last question that came in just under the buzzer.
Right at the buzzer.
Right, that's right.
How close is Nebraska, Penny, this is from Penny, how close is Nebraska's panhandle to being classified as a desert?
Well, that's interesting. That's close. It's what we call semi-arid, which means that there are very dry conditions. I'm trying to bring up Nebraska map here, so there we go. It is semi-arid. It's not quite a desert. I know, for example, places like eastern Colorado, places like Denver and Fort Collins, they average about 16 to 18 inches of rain a year. Scotts Bluff, I believe, I'm not exactly sure, maybe you know this off the top of your head, is a little closer to 20 inches a year, I believe, is about the average. So remember, as far as a desert, 10 inches or less. So portions of the panhandle, maybe 15, 16, 18 inches a year. So really only about 8 inches. So that's why sometimes when we have drought conditions, it can be very dry. And back in the 1930s, when we had the Dust Bowl, it was very dry, and so it didn't take very much for us to see blowing dust, blowing dirt around there because it became so dry. So yes, western Nebraska, the Panhandle, the High Plains, they are close to being a desert, but we still get enough adequate moisture in Scotts Bluff, Chadron, Cheyenne, and Denver not to be a desert. All right. Again, thanks for everyone for tuning in. Appreciate that. Ken, next week on Tuesday, is going to have a fun topic. We're going to be talking about the full moons, all the names of the full moons throughout the year. Flower moon, the corn moon, heard about those. We're going to find out more about that next Tuesday. And then next Thursday, I'm going to be talking about volcanoes, how volcanoes could impact the weather around the world. So again, thank you very much for joining us. We appreciate that, and take care.